Welcome students, welcome to today's lecture. Now today we shall discuss about line integrals. Now what is this line integral? Basically a line integral is an integration which is evaluated along any curve. Curve means it may be a open curve, it may be a closed curve, whatever it is a curve. Okay, so this picture shows you a curve OAP. Suppose a particle goes from O to P through this path. Now in this scenario it is an open curve. Okay, so the line integral associated with this curve will be a open line integral, like this one. This integral C f dot dr is called line integral along this curve C. C may be a, now C is a open curve here, OAP. In some cases it can be expressed as integration OAP f dot dr or integration O to P f dot dr. These three different notations are the same. You can find different notations in different books, but all of them represents open line integral. Now the second scenario is like this. A particle starts from O and along OAP it reaches at P, then it comes back to O through the path PBO. See, this OAPBO is a closed curve. So the line integral associated with this scenario will be called a closed line integral, and in this case it can be expressed as this one. This sign is called closed line integral. Okay, so this one doesn't have this circle and this one have this circle. This is the sign which tells you that yes, this is a closed line integral and this one is a open line integral. Now in some cases, in some books you can find this closed line integral as a path OAPBO. See, this is the initial point and this is the initial point. So you have to close the curve in order to write like this. Now curve OAPBO can be divided into two open curves like OAP and PBO. So in case of evaluation of any closed line integral, you can divide that closed line integral into two open line integrals, as you see here. Now in my present lecture I shall discuss about only open line integrals. In my next lecture I shall discuss about this closed line integrals. Now before I proceed anything, if you are new to my channel, then please do like, share and subscribe to this channel, and of course don't forget to click on the notification bell for regular updates. Okay, now let's proceed. Now before I start any mathematics, you should know some properties and formulas, like this one. In case of open line integral, this thing can be interpreted as total work done along the path given or along the from the initial point to the final point. Suppose F is a force. It's my mistake that there is no vector sign here. I'm very sorry for that. Now let F be a force, and it is acted upon a particle of mass m, which displaces the particle from O, the initial point, to P, the final point, through this OAP curve. Then integral open line integral f dot dr is the estimation of the work done, and the closed line integral, it is actually called the circulation of this vector along the curve this. In aerodynamics or in fluid dynamics, if this f vector denotes the velocity vector, then the closed line integral over f dot dr will be the estimation of the circulation of f around the given curve. Clear? Now, what if f is a conservative vector? In that case, integral I to f dot dr, again the vector is missing. Oh, again sorry for that. Now integration I to f dot dr will be independent of the path joining the point I to f. Suppose f is a conservative vector, then the work done along OAP or OBP will be same. If that differs, then f is not a conservative vector. And for closed line integral, it is 0. So f is conservative, then open line integral is independent of path and closed line integral is 0. Now we all know that if f is a conservative vector, then del cross f equals to 0, and the consequence of this del cross f equals to 0 is f can be written as gradient of phi. What is phi? Phi is a scalar potential, and in these two expressions delta operator is there. This delta operator can be written as I cap del del x plus j cap del del y plus k cap del del z. Actually it is called the nabla operator. It is actually the vector representation of differentiation operator. You are already familiar with ddx operator or ddy operator or say ddz operator, but as you know that the position vector in 3 dimension can be expressed as r equals to I cap x plus j cap y plus k cap z, then like that the vector differentiation operator, the nabla operator, can be represented like this one. Now since it is a vector integration lecture, I cannot explain in details the nabla operator and how it works here, but in my coming lectures I shall discuss about it. But for now, just take it as it is. And the most important property, f dot dr. What is the value of f dot dr now? Now f is equals to grad phi or del phi, and the compact form of this operator can be written as r cap d phi dr or r cap d dr. See, this is an r cap d dr form. So del phi can be written as r cap d dr, d phi dr, and dr can be written as dr cap dr. This is 1 and these two dr cancels out, so f dot dr equals to d phi. See, these formulas are very important for your coming lectures, because in our mathematical problems we shall use them extensively, and in this lecture I am explaining this, but for the coming lectures and the coming problems I shall not explain in so much detail. I just take a problem and use these formulas. So please remember these formulas very carefully. Now let's proceed to our problems now. This is the first problem. a very typical type of line integral problem. Find the work done in moving a particle in the force field. Force is given along, there is two paths, a straight line from 0 0 0 to 2 1 3 and a curve defined by some parametric equations. Now for the first case we have to use a parametric form of some kind. Let's see how. Let's take the parametric form x equal to 2t, y is equal to t, z equals to 3t. Now from where this 2t, t and 3t comes? From this point. See, for this type of problems originating from 0 0 0 to any point, say 3 to 4, 5 to 6, 2 1 3, anything, you can take the parametric form as the last point, like 2t, t, 3t. If it were 1 to 3, then I shall take x equal to 1t, y is equal to 2t, z equal to 3t, and so on. Now it's time to put this parametric form and convert the initial and final point limits to our t limits, like see x, y, z 0 and t is equal to 0. Now put x equal to 2, x equal to 2, so t equal to 1, y equal to 1, so t equal to 1, z equal to 3, so t equal to 1. Hence the limit of t is 0 to 1, and as we have x equal to 2t, we can derive dx, dy, dz like this one. So every variable is now converted to the parametric variable. Now we just put the value of x, y, z in t format, and the value has and the upper and lower limit has been changed to t equals to 0 to 1. So the parametric form of this integration becomes very easy. 0 to 1, 36t square plus 8t, and after necessary calculations we can find that the value of this integration is 16. I know you guys are strong enough to do these small mathematics of your own. Now for the second one. Now see, the second one have parameterized the x, y, z variables into one variable, only x. You can put y is equal to x square by 4, z equal to 3 by 8 x cube. Then you can evaluate or derive dy dz, because the upper and lower limit are given only for x. So it is also a very unique problem. Let's see. F dot dr can be written as like before. Now we have to convert the y and z into x. See, the dx, dy and dz can be converted into x and dx type. Now we have to put in this form 3x square dx untouched. We have put the z equals to 3x cube by 8, y is equal to x square by 4 here, and after simplifying this whole expression we can find that the integration has been converted into 0 to 2, 3x square plus 3 by 8 x to the power 5 minus x cube by 8 plus 27 by 64 x to the power 5 dx. After necessary calculations we can have the value of integration is 16. It's your homework to fill in the necessary calculations between these two lines. It's your homework now. I know you guys can do it. Now let's go to our second problem. Capital F is given. You have to evaluate the open line integral f dot dr. The parametric form of the curve is given, y equal to 2x square, and the points are also given 0 0 to 1 2. Now there is one more thing, you have to test the result through the curve y equal to xs cube along the same points and comment on your answer. Now see, this type of equations actually asks about what is f, like if f is conservative or not. If it is path independent, then it is conservative. If it is not, then it is not. See what happened. For the first curve, we have y equal to 2x square, so we can convert all the y's into x, like dy equal to 4x dx, and let us put y equal to 2x square here and convert this whole thing in x. After simplifying this, we can have these steps like this, and the result is minus 7 by 6. This is for the first curve. Now let's see what happened when we proceed through the second curve. Similarly, we have dy equal to 3x square dx, and the integration as follows, like the first one, but the result is 4 by 15. See, same integration through different paths, and the result is different. So it is path dependent, so it is not a conservative one. So what will be the comment of your answer? F is path dependent and non-conservative vector. Okay. Now let's test our answer. How? If f is conservative, then del cross f equals to 0. If it is not, del cross f is not equals to 0. Let's see. This is del cross f. This is the format of del cross f: I, j, k, del del x, del del y, del del z, and the three components of f. Now see, I cap del del y of 0 minus del del z of minus y square. So the x component is 0. Minus j cap, it is del del x of 0 minus del del z of 3xy. Again, nothing there. Plus k cap, del del x of minus y square, 0, minus del del z of 3xy. So there is a non-zero quantity. Sorry for again, because I have just missed the minus sign here. It will be minus k cap 3x, but whatever, it is not 0. So in your paper, in your exam, if you want to test your result, that whether you are right or wrong, you can test your result like this. But don't do unless and until you are not sure, because it will take some time, and in exam hall, time is everything. Now let's proceed to our next problem. Evaluate this integral where f is given, and now the curve is a known curve: x square plus y square equals to 1 square, a circle of radius 1. It is very interesting one, because we can use this x square plus y square equals to 1 here. So f will be a simplified form. Let's see how. Now f dot dr equals to this dot dr means I cap dx plus j cap dy plus k cap dz, and now we can put this x square plus y square equals to 1. So the whole thing becomes very easy. Now we can use the parametric form. Why? Because nothing is given here, not even the lower and upper limit. So you have to find the parametric form and the parametric lower and upper limit, then proceed. Since it is a circle, x equal to r cos theta, y is equal to r sin theta, r equal to 1, so we have parametric equation like x equal to 1 cos theta, y equal to 1 sin theta, and we have for x dx equal to minus sin theta d theta. Similarly, dy equal to cos theta d theta. Now, since it is a circle, what is the limit of theta? 0 to 360 degree or 2 pi. So the lower limit is 0 and upper limit is 2 pi. Hence, we have our integration as 0 to 2 pi. For y, this is sin theta, dx, this is minus sin theta d theta, and the rest is like that. we have to just simplify this like this. Sin sine square theta cos square theta plus equals to 1. So it is very easy now, minus 2 pi. See, these type of problems are very easy unless and until you catch the right kind of parametric format. And each curve have its own different parametric form. Like circle has its own, parabola has its own, and like that ellipse or hyperbola. So you have to catch the proper parametric form for a proper curve unless and until it is given like the previous ones. Now our fourth problem. Show that this integral is independent of the path joining the points this and 3, 4. Now it is a very straight cut question that you have to evaluate the f from the f dot dr f, and since it is independent of the path, del cross f will be 0. This is the scheme, and further we have to use the f dot dr equal to d phi format to evaluate the integral. Like we can rearrange this like this. This is our f and this is our dr. So f can be written as this one. Now we have to do a cross product because f is independent. We have to show that. So del cross f should be 0. Del cross f is written here. Now I cap del y of 0 minus del z of this one, this is 0. For j, del x of 0 minus del z of this one, that's also 0. For k, del x of this one gives you 2xy plus 3y square, and del y of this one gives you 2xy plus 3y square. So these things cancels out each other and the whole thing becomes 0. So the half of the problem is done. Show that the integral is independent of path. Since f is conservative, this integral will be independent of path. Now we have to evaluate the integral, and for that we have our very easy formula, d phi equals to f dot dr. So d phi is equal to this one. Now for this kind of problems you have to rearrange this thing like d of something. See, xy square dx plus x square y dy, that can be arranged in a bracket, and y cube dx plus 3xy square dy, that can be arranged in another bracket. Why? Because this thing can be written as d of half of x square y square. You can expand it like, see, half 2xy square plus half 2x square y. 2 and half cancels out and this thing comes out. Similarly, this thing is just d of xy cube. So d phi is equal to d of half of x square plus y square plus xy cube. So phi is equals to integration of that one and becomes this. Now we have to put the upper and lower limit here, like f dot dr equals to this thing. Upon putting the upper and lower limit properly, we have our result as 254. You can calculate the upper and lower limit here of your own and test the result. Now let's proceed to our next question. See, f is given and now it is open line integral f cross dr. It is a quite interesting problem because parametric forms are given, but this thing is not so much known to you. This is not f dot dr, this is f cross dr. So f cross dr will have some component like vector like components like this one. Okay, now we have we have to put this parametric forms and convert this into t forms, but the components will remain. It is not a scalar quantity. So x equal to cos t, we have dx, dy and dz. Now we have to put these forms in here. Let's put all the x, y, z and dx, dy, dz properly. After the calculations, we can have that f cross dr equal to I cap this thing dt minus j cap this thing dt, because there is no k cap term. K cap terms have been cancelled out each other. Now what is the limit of t from t equal to 0 to t equal to pi by 2? Let's do it. Remember, in my first lecture I have told you that whenever you do any vector integration like this type of vector integration, you have to evaluate them separately. See, I cap integration of this thing minus j cap integration of this thing. Otherwise, there will be chances of mistakes, and if you mistake at this point, everything is gone. Everything. So after necessary calculations, we can find that the value of this integral is I cap 2 minus pi by 4 minus j cap half minus pi. You can be sure for yourself, do the maths step by step properly, and the answer will be this type. Now see, this is also a type of line integral, but this is not of your known type. So don't expect the questions to be of your known type always. Yeah, I have shown various types of questions here, and among them integration over C f dot dr is a very common, but you can face this type of questions too. So this is the end of our lecture today. In my coming lectures, I shall discuss about the closed line integrals. Thanks for watching, guys. See you in next lecture.